So today we are talking functions and relations. A relation, anybody remember what those are? Kind of. It's really just an ordered pair. We're just putting two things together. So usually in an ordered pair, we have an x and a y. We call the x the input, and the y is the output. Now, a function is when you have whatever you put in only spits one number back out. It doesn't spit two numbers back out. So functions are when for every input there is exactly one output, is what we always like to say. So functions are just relations where each input has exactly one output. It doesn't matter if a whole bunch of inputs have the same output. Who cares? What matters is that for when you plug something in, only one thing comes out. For example, if I ask you how old you are, there's only one answer to that. I mean, you could give it in different units. You could say, I'm 14, or I'm whatever many months that is. You could say, I'm 168 months old. It's the same thing, right? You have one age at a time. You can't be both 14 and 15 at the same time. Get what I'm saying? So, your age, I plug in, I say, okay, Kristen, what's your age? And Kristen says,
14.
There you go. So I plugged in a value for X, Kristen, and she spat out an answer for Y, 14. Could a whole bunch of you be 14? Sure. That doesn't break anything. That's fine. But when I plug something in, only one thing can come back out. Make sense?
So why would we use that expression anyways? All the things we look at, usually there's only two. In an ordered pair, there's only two numbers. So why would there ever be a?
Because you could have a grouping. So if I guess I should clarify. A function isn't just one relation. It could be a group of them. So if I had a group of ordered pairs, and you saw when I plugged in x, let's say I plugged in x value of 2, and one answer came out with a 1, and then I plugged in 2 again, and then it came out with a 7. Well, that can't be in a function. So functions have to have, when I plug in a number for x, only one number can come out for y. You with me so far? It'll make a little bit more sense, I think, as we do some examples. But let's finish up our vocab first. Okay, so a couple more things. I noted here that we call X input and Y output. It gets a little confusing because we can also refer to the X as the, so everybody remember? Starts with a D. Domain. So these are your input values, or X's. And then, of course, what domain is, what's that other word that's always with domain? Range. Domain and range. These are your output values. Oops. Or, that's an or. Oh, wait. Yeah, or X's. Your output values, or Y's. Okay, so let's try some things here. Let's say I gave you a bunch of ordered pairs. How about 1, 1, 2, 5, -3, 6, and 4, 2, something like that. If I gave you this relation, so it's just this grouping of ordered pairs, and I asked you to name for me the domain of this relation, give the domain of the above relation. It's super easy. All you have to do, what's domain again? The x values. You literally just list the x values. That's it. So we usually write it like this: x equals, and then these, are you familiar with these curly brackets? So whenever you have more than one answer, if you're listing, well, I guess you could do it for just a single answer, but usually we see it more often if there's a list of answers. We put them in these curly brackets. They're different than parentheses. Parentheses, like these, indicate an ordered pair. Curly brackets is just, hey, here's a list of my answers, that's all. So, what's my domain? If you're just listing the x values, what will go in there? Liliana? They don't have to be. It's a good habit to get into, but it's just a listing. So if I said, oh, hey, what are your siblings' names? I don't care what order they're in. So it's a good habit to get into, to list them in order, but it doesn't have to be. That's it. You just list them. So let's actually note that order doesn't matter. Because it's just a listing. So if I asked you to give the range, the range, of course, is your y value. So we'd have a y equals funny bracket. And then what goes in my range? Taylor? 1, 5, 6, 2. That's it. Order doesn't matter here either because it's just a listing. Again, it's convenient, especially for me, if you put them in order. So when I'm checking them, everybody does it the same way, but it's not necessary. So that's it for domain and range, yeah.
Wait, what did you say the squiggly lines were?
You use them when you have a list of answers. You can use it for just a single answer, but usually we only see it when we have more than one answer that belongs in there. If you don't put the squigglies, it's not the end of the world. But eventually, you'll see this a lot as you work your way up the math class ladder. You'll see this notation more and more. So it's just a way for me to say, these are all my answers. Okay. Is this relation a function? That's my next question. Is the above relation a function? This one is. How do you know? Well, you're going to look. When I plugged in 1, I got out an answer of 1. I never plugged in 1 again, so when I put in 1, I only got one answer back out. When I plugged in 2, I only got one answer out. I got out 5. When I plugged in -3, I only got one number out. It was 6. When I plugged in 4, I only got one number out. It was 2. So, yes, this is a function. Every input has one output. So, Mrs. Avia, I'm confused. What would it look like if it wasn't a function? I'll show you. Say you had something like this. Do you see why this is not a function? Yes. When I plugged in a 2, I got out a 3. But then when I plugged in 2 again, I got out a different answer. That can't be. You get what I'm saying? So if I ask Kristen how old she is, you didn't happen to just turn 15 in the last 2 minutes, did you? No. So if I ask Kristen how old she is, she spits out an answer. If I ask her again later on, she's got to spit out the same answer. You know what I'm saying? So here, I plugged in 2, it spat out a 3, but then I tried it again, now it spit out a 7. If that happens, this thing can't be a function. This is not a function. No. The x's, let's say the x value of 2 has 2 different outputs. Outputs. So that's why that thing is not a function. So far we're all right? Easy enough? So if I give you a list of ordered pairs, domain is just all the x values, range is all the y values, and then you really just look, do any of your x's repeat? If they do, it's not a function. If they don't, it is a function. There's some other ways that we write our ordered pairs instead of just like a list like this. We could write them in what's called a mapping diagram. So let's see, I'll put that, oh, I can put it here. So let's just say I took my relation from above, this one right here, and I wanted to write that as a mapping diagram. So check out how cool this is. You just have one bubble that's your x values and one bubble that's your y's. And then all the x's in there were what? I had 1, 2, -3, and 4. And the y's, I had 1, 5, 6, and 2. And then all you do, again, order doesn't matter in these bubbles either. You literally just draw an arrow from whatever the x was to its corresponding y. So when I plugged in a 2, I got out a 5. -3, I got out a 6. And a 4, I got out a 2. So instead of writing it as a list of ordered pairs, you might see it like this. Is this thing a function? Yeah, look, every x goes to exactly one y. So this was a yes, it's a function. But we already knew that. I can make a mapping diagram of the other one too. Whoa. I have x's, I have y's. I'm going to mix up the order now just so it looks a little bit more fun. So if let me put them in numerical order. Well, 0, 2, 5. And then on this side I'd have -4, -1, 3, 7. 0 went to -4. 2 went to 3. 5 went to -1. And then 2 went to 7. Was this thing a function? No, and you can very clearly see it here because I have one of my x values, the 2, going to 2 different places. I'm going to try and trick you. I'm going to draw you a new mapping diagram, and I want you to tell me if that thing would be a function or not. Okay, ready? Decide for yourself if this thing represents a function or not. Okay, does it? Is this a function? I'm hearing yes and no's. Remember the definition of a function. Every input can only have one output. It doesn't matter if multiple inputs have the same output. Just like a whole bunch of you can all be 14, but you can only be one age at a time. So, is it a function? Yes! 0 only went to one number. -1 only went to one number. It doesn't matter that they just so happen to go to the same number. It's just, I can only have one arrow coming off of each of my x's. If you had 2 arrows coming off of any of your x's, that's no longer a function. Everybody could go to 4. It doesn't matter. What matters is the x's. Every input can only have one output. So this is a yes. Okay. Does that make sense so far? Let's try one more, just for fun. What about this one? Function or not?
Not. Not.
Why no? Yeah, no, it's not.
Oh, no. What am I?
This is not a function. 4 is going to 3 different places. That can't be. That's a no. One more. Function, yes or no? Yes. It doesn't matter if all the numbers go to the same number. Each number can only have one output. Each input can only have one output, and that's the case there. Okay. So there's that. Then, the next part might be one of your favorite parts because it's so easy. Sometimes with our relations, we show them as a graph instead of as a list of ordered pairs or as a mapping diagram. There's such an easy and fun way to tell if a relation is a function if you have a graph. Yes?
You use a straight line and you put it across the graph lines intersect with a straight line, then it's not a function.
That's it. It's called the vertical line test. So if I have a graph, let me just, I'm just going to make one up. So I had a graph that looks something like this. I don't know. How about or something like that. Okay, so this blue line is my graph. All you have to do is you take a vertical line, it has to be a vertical line, and you're going to pass the vertical line along your graph. As long as your vertical line only ever intersects your graph once at any point, it's fine. That is a function. So this one, yes, would be a function. Yes. Passes the vertical line test. So it is a function. Something that would not pass the vertical line test might look something like, I don't know. Say we did a little loop-de-loo here. So if I'm looking at my blue graph, not the axes don't count for anything. It's the blue graph. So imagine the green lines weren't even there. But as I move my vertical line along this, see right here, ding, ding, ding? It's hitting the popsicle stick multiple times, 3 times in fact. Here, all these places, it's violating the, so here, if we just take, here's my vertical line. Look how it's hitting more than once. It's hitting once, twice, 3 times. Fails the vertical line test.
What about at the end?
Doesn't matter. If any piece of it fails, the whole thing fails. Good question. Yes. Hurry. So again, if any piece fails, the whole graph fails. Easy enough so far? You sure? Okay. So the next thing let's pause right here.